Who or what are flying mud doctors?
How does this material keep Navy airmen flying?
Why is a metal bin a symbol of progress?
Why are Iowans good judges of seafood?
Industry on Parade, Peabody Award winner for public service, produced on film each week by the National Association of Manufacturers.
10,000 gallons of mud circulating through an oil well being drilled in the Delta swamplands. The mud brings up cuttings, seals the walls of the hole, and performs other essential functions. But when the mud sprays out of the drill hole like this, it's a sure sign of a gas cut down in the well. The drill has opened a pocket of natural gas that could blow out everything. They shut down in a hurry and put through a radio telephone call to the doctor. The mud doctor, a specialist in solving well drilling problems by varying the makeup of the mud being used as a drilling fluid. Every hour that drilling operations are suspended means thousands of dollars lost. So the mud doctor wastes no more time answering a call than would your family MD. Along the Mississippi Delta, that usually means flying into the drill site. There's the well. All he has to do now is find a good straight bayou and put the plane down. Often, the mud doctor arrives at a well less than an hour after trouble develops. With him in the plane is a portable laboratory, a collection of equipment for determining all sorts of things about conditions underground, just by analyzing the mud coming out of the hole. Actually, of course, the mud is not mere liquefied soil, although originally that's exactly what it was. Today, it's a most carefully compounded mixture of chemical elements, scientifically designed for a specific drilling job. But it still looks like mere mud, and the original name continues in use. If any really tricky problem were encountered, too complicated for solution in the field, samples would be rushed here to the mud doctor's home base, the Baroid Division of the National Lead Company in Houston. In these laboratories, the mud engineers are able to arrive at amazingly perceptive conclusions about the sort of substratum a drill bit is digging into hundreds of miles away, and what to do about it. But whether the conclusions are reached in Houston or in the field, the result is a corrective prescription. In this case, additional barium sulfate, to counteract that gas pressure underground, and yet just enough to keep the mud flowing freely and the costly drilling operation proceeding on schedule. Tool pushers, drillers, riggers, and other oil industry personnel recognize as well as any group of workers in all industry how dependent they and we, the consumers, are on the round-the-clock industrial research that keeps the wheels turning for them and for us.
America's new frontiers are pushed back every day somewhere in this country through research. Each year, industry spends $2.5 billion in research to discover new products or improve those already on the market. These new and improved products mean better and less expensive things for all of us. But more important, they mean more and better jobs with an ever greater chance for better living for everybody. This can happen only in America, where industry is free to experiment, where men know they can refuse to accept limitation, where we have a competitive enterprise system in which nothing is impossible.
A downed airman bobs in a freezing sea. Except for understandable concern about arrangements to get him out of here, he's quite comfortable. Thanks to the whirlybird and his immersion suit, he'll be flying again tomorrow. An important part of that immersion suit originated here at the JenCel-Lite Corporation plant in Seattle, where fibers of wool and acetate are roughly blended like this before being dumped into a machine that will mix them more thoroughly. Surprisingly, it's neither the wool nor the acetate which provides the warmth assured by the insulating material manufactured here. Rather, it's the permanent air cells created by the two fibers in combination. The combining of the two is accomplished like this. Now the fibers, 66% wool, 34% acetate, are carded. This fluffs up the fibers and lays them all in the same direction. The wool has tiny natural barbs which interlock with the acetate and form those tiny pockets of air we mentioned, the air cells that so effectively bar the passage of heat and cold. This firmly intertwined mixture is deposited layer by layer on a slowly moving belt of fabric, building up into a bat. Nothing more is done to the batting here. It's shipped out in this form to the fabricators of sports and foul weather garments like Sportscasters Incorporated, who use it as an insulating liner for their products, first stitching it between layers of bird cloth or other comparable materials. This quilting compresses the springy batting to a fraction of its normal thickness, thus further increasing its insulating properties. Now it can be cut into any shape required for snowsuit, flight jacket, sleeping bag, ski togs, or any other form of apparel designed to keep the human form compactly, snugly protected against the elements. A product of industrial research during World War II, it's now finding widespread applications under much happier conditions.
Metal workers in a factory in Beatrice, Nebraska, bend sheet aluminum on a big press brake, forming a large square bin. Seems like a fairly routine operation, but in fact these men are participants in one of the most drastic changes to come over American industry during recent years, namely, the improvement in methods of handling materials. Viewers of Industry on Parade have seen in action a multitude of different kinds of conveyor systems, fork trucks, and other mechanical devices designed to relieve men of the back-breaking jobs of lifting and carrying. Well, here being made is another such device called a tote bin, and it will do a lot more than ease man's labor and thus increase his productiveness and his income. We'll get back to what else it does in a moment. Now, let's see how tote bins are put together. The front and two sides, all formed from one piece of aluminum, are placed in a Hella arc welding machine along with the piece that will be the back. Now the body of the bin will be held rigidly in shape and joined by a continuous weld that eliminates distortion. Next step is to add the bottom and legs. At first, the various parts are merely tack welded together. Then a finish welder goes over every seam, making the bin completely watertight and pressure tight. When this job is done, the hinged emptying door that goes at the bottom of the front panel is installed. Except for finishing and the addition of certain hardware, the job is done. The bin is ready to go to work, transporting, storing, and measuring out bulk materials of all kinds. Sugar, grains, chemicals, cement, coffee, soaps, and detergents. An almost endless list of products that until now have had to be handled in small bags and consequently have had to be protected against moisture, rough handling, high shipping costs, insects, and other hazards. For example, take the flour being delivered to the interstate bakeries in Kansas City. Instead of arriving in bags, it comes in tote bins, which shuttle back and forth constantly between bakery and flour mill. No dusty, wasteful, tedious opening of bags. The flour is already in the airtight bins, ready for convenient storage as long as necessary, or ready to be discharged into the mixing kettles by screw conveyor. Again, we say, to the casual observer, it looks like a routine operation. But the new materials handling equipment actually means better bread and other products turned out under the most scrupulously sanitary conditions and at savings in cost that are reflected in the price paid by the consumers.
Brand new Americans are arriving at a record rate. About 7,000 citizens are added to our population every 24 hours. By 1975, it is estimated we'll have a population of some 220 million persons. These new Americans will need a great many things from babyhood to voting age. Businessmen are planning today for the 10 to 15 million new families we'll have in 1975. It's up to every one of us to help maintain a strong and vigorous enterprise system if we are to fulfill the needs and desires of an ever-growing America.
Let's go way down east to Damariscotta, Maine, and learn how it is that more and more Americans in even the most inland regions are becoming connoisseurs of fine, fresh seafood. Here at an establishment called Saltwater Farm, lobsters measuring 3.5 to 5 inches along the main body shell are shipped out live to all parts of the country. After being measured and otherwise inspected, the lobsters, with their claws pegged to keep them from injuring each other, wait in tanks of circulating ocean water until the order comes in, say from Olwine, Iowa. Then they're weighed out, and the best weight for eating, we learn, is 1 1/8 pounds or a little more. Into a steel shipping and cooking container goes a handful of Maine rockweed to provide moisture and cushion the lobsters in transit, and in these parts, a traditional and necessary element for cooking the crustaceans. Another handful of rockweed on top, and we're ready to go. The lid is put on, and now the metal container will be placed in a pine barrel. Now, around, under and over the container of lobsters, he'll pack 100 pounds of ice. If the distance they have to travel is very great, Railway Express will add more ice along the way. In any case, the shipper guarantees the lobsters will arrive alive and kicking. Off comes the elm hoop, on goes the burlap cover. Then the hoop is replaced, and all we have to do is meet the next train to Boston and point south and west. In Boston, a couple of hours from now, the barrels will be transferred quickly to trains bound for all parts of the country. New Orleans, Cleveland, St. Louis, or Olwine. Whatever the destination, the lobsters remain as vigorous as they were while beating about in the Atlantic. Though they've never even seen the ocean, these youngsters recognize a good seafood dinner as well as the saltiest down easter.